Up until this point in the course, we've studied how things move, how fast, how far, and how much they accelerate by. The field of describing how an object moves is called kinematics. Now we will study why things move. What is the cause of this change in movement? The field that we're studying now is called dynamics. This chapter is probably one of the most important chapters we will study. It is important that you understand why things interact as they do. Many of the concepts that we develop later on will be pivotal to your understanding of this chapter. So let's start with our first concept, force. Now, if I were to explain the word force to, say, my 2-year-old son, I'd just say that it's just simply a push or a pull. But I'd have to refine this idea a bit more for you guys and say that it is really the influence or the interaction between two objects, or an object between its environment. Now, maybe this is a bit vague. Let's dive in a little bit deeper. Imagine you're kicking a football, and as you kick the football, there is some agent that exerts force. And in this case, this would be your foot pushing a force onto the ball. So that's what we would call as the agent, which causes this football to undergo some change in movement. So a force is an interaction between two objects that causes some change in movement. Or if it doesn't move, then a change in its geometry, like it gets indented or something like that. When you push or pull or kick an object, you exert a force either softly or very hard. Also, when you push or pull an object, you push or pull in a certain direction, like right or left or up or down. Hence, force is a vector. It has both a magnitude and a direction. There are two basic classes of forces. We have contact forces, which are essentially forces that are exerted between objects that are physically touching each other. Example, like kicking this ball. There are also forces called long-range forces, or action at a distance force, that don't require the two objects to be physically touching each other. For example, gravity is a long-range force. You don't need to be in contact with the surface of the Earth to feel the Earth's gravitational pull on you. Other long-range forces that we'll see are the electric and magnetic forces that we'll study in the second semester. Below, I have a list of many different types of forces that we'll come to know in this course. Let's start off with the normal force, which I symbolize with an F sub n, to remind you it's a force, and the n here, capital N, means normal force, or sometimes you'll see written as just simply a capital N. Now, the normal force is a force that is perpendicular to the surface. Sometimes we call it a support force. For example, you can see there's a box over here on the left side that's resting on the ground, or the surface. The surface below is exerting a force upwards. It's pushing it upwards, preventing this object from penetrating the surface. If the surface weren't there, then the object would fall straight through. So that's what we call the normal force. Now you might be wondering, why do we call it the normal force instead of the support force? Well, mathematicians refer to a line that is perpendicular to a plane, like a surface, as the normal to the surface. So that's where the word normal comes in. Normal means perpendicular to a surface. By the way, notice that if I tilt the surface here at an angle, the normal is still perpendicular to the surface. Next, on to our next force. I'm sure you've heard about the term friction. This is another type of contact force, like the last one that we just discussed, but in this case, the normal force was acting perpendicular to the surface, whereas the frictional force acts parallel to the surface. When an object slides across a rough surface, there's a friction force acting on the object. It's trying to prevent the object from keep moving to the right and eventually could cause the object to slow down. Now there are two types of frictional forces that we'll study. I haven't listed them down below here. I've only just given you just a general definition of friction, but let me just tell you a little bit about them briefly. One is called static friction force, and the second is called the kinetic frictional force. When an object slides across a table, this slipping or sliding is a friction that we call kinetic. It's a moving type of friction. If an object like a car is parked on a hill, the car is not slipping or sliding. Let's say it's just stationary on this parked hill. There's a force that is preventing this car from starting to slide. And that's another type of friction force. That's what we call the static friction. In this case, the object is stationary or at rest. Anyway, we'll discuss friction in much more detail later in this chapter. Let's move on to the next force. We have tension here. Now, this is a force that is exerted between a rope or a cord or a chain that is attached to some object like you can see over here. The force that is exerted on this object is directed along the direction of the rope or the cord or the chain or whatever it may be. So we call forces that pull along the direction of a chain or a string or a tendon even as a tension force, which we label as a capital T or a F sub T. You'll notice I like to name all my forces with an F and a subscript, but sometimes I'll utilize a capital T. I don't like this so much, but I do use it. The reason why I don't use the capital T is that sometimes students will confuse this capital T with the symbol that we use for the period. Remember, the time period is the same symbol, capital T. Another very similar force to the tension force is one that arises from a stretched or a compressed spring. So the pushing or the pulling of a spring is called the spring force, or also called the elastic force. And now on to one of the 4 fundamental forces in nature, gravity. Oddly, gravity is actually the weakest of the fundamental forces in nature. There are, by the way, 4 of them: gravity, electromagnetic, strong force, and weak nuclear force. Gravity is a long-range force. We call it the gravitational force between an object and another. You'll later learn that it depends on the masses of the objects, and it gets weaker as you get further and further away, the two objects. We'll study in more detail the gravitational attraction between, say, a body and the Earth, for example, and this is called Newton's universal law of gravitation. For now, you can just think of gravitation attraction as just simply weight. I like to symbolize the weight of an object as the force of gravity, F sub g here, instead of just using the capital W that is used in some textbooks, because I want to remind you that weight is a force of gravity. Next we have drag. Drag is a type of frictional force. It's a resistive force, or sometimes called air resistance, that is a frictional force that rises within a fluid. And fluids are gases or liquids. Sometimes we call this drag a fluid friction. You can see these leaves falling from the tree, and the drag force is in the opposite direction of the movement. Thrust is a force from a rocket or an airplane or a boat, etc., that propels the object forwards by something like an engine or some other agent. The electric and magnetic forces will be studied in a lot more detail in the second semester. Collectively, these forces are known as the electromagnetic force, and the electromagnetic force is the second of the fundamental forces of nature that we learn. Not listed in the notes are 2 other fundamental forces we will discuss when we get to the end of the course, when we study our modern physics or nuclear physics unit. They are the strong nuclear force, which is a force that holds the protons and neutrons together in the atomic nucleus, and then the weak force, which manifests itself through radioactive decay, and we'll study that later on in nuclear physics. Anyhow, you can see that there are many different types of forces that we'll come to see. Maybe someday physicists will be able to unify all of these forces in terms of one single interaction.